How's it going, guys? Matt here with Code Tech Tutorials. Today we're going to look at C++ and talk about return types. This is sort of a beginner type of thing, so a lot of you might already know this, but if you don't necessarily, or you just want a refresher, stay tuned. Alright, so I'm using Windows here, and I opened Visual Studio, and we're doing a CMake project, so that's the setup there. And we're just going to hit next here, and we're going to go return type demo. So just a quick place where I can put some code while I talk about this stuff. Alright, so return types. What I mean by return types is basically when you write a function, you often want to return some kind of variable or some kind of object, or sometimes just modify one. So I want to talk about the main ways this is done, and that's basically going to be the video. Okay, so we got our main here, and main is a function that returns an integer, notably. So that's the main, most standard way, is to just, you have the return type here before your function declaration, and you return something that matches. 0 is an integer, so that'll be happy. But often you want to do special things with functions. Like let's make maybe a little game setup type thing. Let's say, for example, I'm going to make this a very contrived, basic example to start. Let's say we want to make a player character. Maybe we're trying to make a little game and we want to have hit points and stuff like that. I like these kind of examples because they're often easy for people to wrap their head around and not necessarily so abstract. All right, so you think, all right, we have a player. We want HP, and maybe we'll do this as a float, and we want float. I don't know, let's go with action points. Well, maybe action points are more set in stone, so we don't want a floating point on that. We just want an integer. And maybe we have something like, well, let's go with string here. We have a player name that you can set. Just some basic stuff. And let's be sure to include string over that. So HP, action points, and maybe we'll have a few other things like strength, intellect, sure. Just a couple hint. Let's spell these out. Strength, just a few stats to play around with. And let's type this hit points out too, but hit points are going to be a float. And we'll go with this style. So there's like all our player stuff. And I know this already has some stuff that you're probably right off the bat thinking, oh, that can be approved. But we'll get to that. For sake of example, we're going to start it out like this. Say, you don't really want to make your program complicated. You just want to have one file, and so whatever, you declare globals. You think this is fine for now, which, I mean, it's going to work. If it works, that's the majority of the battle, so maybe it is fine. And let's say you want to go into your game, and the first thing you want to do is like set your hit points, and you want to set all your stats. So you'll do something like player name equals, I don't know, let's do a get line and have them take input for that. All right, so here's copy elision. And since C++11 omits copy constructors, resulting in zero copy pass by value semantics. So these are called pass by value when you're not doing a reference, like getLine was. GetLine takes in player name by reference, so it's going to be pretty guaranteed to not make a copy. However, this is going to make a copy. So we're kind of looking at like, some function. T is just some type here. When you call it, it's going to return the type constructed, but it's going to make a copy. But however, this one here, this kind of gets into some deeper stuff that I don't necessarily want to complicate this episode with. But the basic point here is there are cases when it's going to still make a copy, and there are cases where it's going to properly move your data and not necessarily make a copy. And you basically kind of have to study this and fully understand it to know whether it's doing that or not. So in general, it's probably not the best thing to rely on this little feature because, well, it's also going to just differ in different compilers. So if you're sharing your code, your results may vary in different places. So what we can do instead is, well, we got the return type of a float, but we could also just return void. And we could take in the hit points. It's a float. Take it in by reference and just call it HP here. It doesn't need the same name. And we can just set it to that. HP equals 10. And that way it's taken in a reference, so it's not making a copy there, and it's just setting it. And since it's a reference, it's the real variable. And that would work as well. So we just, rather than put it over here for the return side, we just pass it in here. And that might be a slightly better way of doing it. And we can propagate that and do these the same way. However, we're going to get a whole bunch of functions after a while. And if, all of them are just set default, whatever action points and so on, rather than returning, we've got this method. This is essentially called a return to. Usually when people make functions like this, they preface these variables with something like out. That way it's clear when you're reading the code, especially if it's a huge function, that this is essentially an output. Now, if you don't want this to be an output, but you still don't want to copy in the variable, you could mark it const, and then const will not allow it to be changed. So this will result in a compiler error. So you can still keep your function efficient by not making copies and these pass in values by doing that. But if you got to change it, then you can't make it const. And let's go hit this. This should be an int. And you can kind of imagine, I'll call this AP, out AP. You can kind of imagine how you could propagate the rest of these and do it essentially the same way. So there's two methods of doing it. You either pass it in by reference and set it in the function, or you just return it. And either are pretty much okay. The return over here just risks making a copy unless you're really up on exactly how you're handling everything. Now, you can do tricky stuff like you can return a reference to a float, for example, and do the same function, not take anything there, and then just say return n.f. And that's a valid function too, and it's going to return a reference to this. But this is actually rather confusing because this is just in a local space. This might even error out. I don't know. Let's see what it does. Let's see what happens here. We'll set it to 20 there. So if we call this function, and there's a bit of a, the functions are the same name, but since they have different signatures here, it will know which one we're talking about. All right, so here we should see that hit points is 20, but we can also, you know, you got to think about this. Are we returning a reference to this 20? What is going to happen there? I don't know. Let's find out. And I definitely encourage you to experiment a lot with code like this. If you're not sure what's going on, just check it out and see what happens. And there's an error, and it can't convert this float to a reference to a float. So there's a little bit of an error. But if we just get rid of this reference, then it's going to be fine. It'll do it. Player name ASDF, there's the HP. So that worked. So you can, while you can return references, you're not going to be able to, in general, return a reference to something you've created in the function. It would have to be something outside. Like, let's say up here we have a float called, I don't know, default hit points. Then, and we set this right off the bat to 20. And I don't know, we could make it const AXPR if we want. But what if we return this? Could we return this by reference? I don't know. Let's have a check. So notice it's not being declared in the function. This is just something that's just always in your program, basically, since it's global there. And it also fails again. It can't return const float to a float. And let's take off the const stuff. See what happens then. It works, and you still get 20. So you can do stuff like that too, because you know, you're able to get a reference from it, and it stays around. The problem with creating it in the function and then trying to return a reference to it, well, once this goes out of scope, it's going to delete all this stuff with the cleanup, and it's no longer going to be sticking around. So it's not even going to know what the reference is. It's just going to be to some kind of dangling, I guess it would be something like a dangling pointer. I can't remember what it's called in this exact case. So there's that. Let's, I guess I should mention some pointer stuff too. Like what if, for example, we wanted to go, okay, let's set default hit points, but what if we just want to take, a pointer to our HP? So what is this going to do? Alt HP equals, I don't know, we'll say 30 in this case. They should all be the same if they're all defaults, but I'm just changing the numbers for sake of this different cout stuff. All right, so what happens here if you try to call it with that one? All right, so let's comment these out for a second. Go set default hit points, and the functions all have the same name, but we know if we pass in just the HP, it's going to use this one. If we don't pass in anything, it's going to use this one. If we pass in a pointer to a float, it's going to use this one. So let's pass in a pointer to a float. And then you might be saying, oh, but wait, our float is not a pointer currently. What you have to do is put a and symbol in front of it here, and that will make a pointer to it. And so then in that case, we'll be passing in a pointer to our hit points. It's not the exact variable. We're not passing in the variable. We're passing in a pointer to our variable. So through that pointer, we can still get to the real variable, but not like this. That's going to throw an error. Let's just hit play and show the error. And it'll say cannot convert float to float star. So what do we do here? Well, we know that in this case right here, that this one is a pointer and we can't just set it directly to a float. What we have to do is dereference it by putting a star in front of it. And that says, it says whatever it's pointing to, basically. So if you have a pointer and you dereference it with another one of these stars, it points to the real variable again. So that should work, and we should get a 30. Let's see if that works. Put in a random name, and 30. There it is. So that's another way you can pass in. Now this isn't quite as efficient as passing in by reference, because when you pass in by reference, you're, I might be mistaken in this, so correct me if I'm wrong. When you're passing in by reference, you're passing in the real variable, basically, or a reference to it, which might create a pointer under the hood. I'm not entirely sure, but it's pretty darn efficient because if you've got some big object, you're not passing in the whole thing. You're just passing in a reference to it, which is just basically a pointer, but not actually a pointer. But technically, I don't know. It's kind of weird. Basically, it's just a small thing that says here it is, kind of like a pointer, except, it, I think, obfuscates to the real thing. Whereas when you're passing in a pointer, it's known as the data type of being a pointer to that object, so you've got to dereference it to get the real thing. So this one here definitely creates a pointer, and then you've got to dereference the pointer, which is a little bit more work. So this is probably a tiny bit less efficient, but these are pretty much on par for some of the most efficient ways to return stuff without making accidental copies. This also works too, but this is a little more dangerous because we don't necessarily know the lifetime of these hit points. So if the lifetime of this hit points changes, then we could be in trouble, because if that gets deleted or something, then we really have no idea what it's doing. So we could mess around with this a little bit more. We could say it's a float pointer, and let's set it equal to a new float 20. So it'll do that at the startup. Can we still return a reference to it like this? Not quite. But if we go, what would we have to do? I think we put a star in front of it to dereference this, and then we should be able to do it. That might work. All right, so let's try that out. Let's compile again. Use that function. It's going to be this one here, and it's going to go off of this here, and let's see what happens there. It works, and it does the right thing. So you might ask, okay, why? That's really weird. Why? Well, because we're dereferencing it, and then we're just returning a reference to this hit points variable in there. So a lot of jumping around the memory, maybe unnecessary in this case, but this happens a lot in programs. Okay, but the problem with this function is, what if someone goes in your main, what if the first thing they do is they go delete default hit points, and now there's nothing there. It's gonna void out the memory. It's not technically gonna void out the memory. It's basically gonna say this points to nothing, or this points to an area of memory that we don't necessarily know what it's guaranteed to be. If you really want to make it zeros, even in this case, this area of memory might still be the same thing, but this pointer is not going to be necessarily pointing to the right spot. I think that's correct. So we could say that this equals null, and then it would definitely be nothing. That's usually what you do when you delete. You delete it, and then you set the memory that's pointing to 0, because the memory that's pointing to doesn't necessarily change when you delete. It just makes random stuff. It's not known anymore. So like this here, even though we delete it, this might still work correctly, because this area still might end up being memory that's 20, but there's no guarantee of that, and your program doesn't know that anymore, so it's undefined. So let's try it. I think we'll actually get 20. Nope, we don't. We get some random stuff. So it put different stuff in the memory. It's basically an area that's marked as free by your operating system, and who knows what your operating system's going to put in there. But if it doesn't end up putting anything in there, you could still end up with 20, which is why it's undefined. So that's the problem with this, is someone could delete this area, and then this function doesn't work correctly anymore. So you got to be careful with that stuff. That's generally why you avoid this type of stuff. And, once again, if we just wanted to be super safe, like this function right here, just returning this, that's still going to be fine. It's probably not going to make a copy, thanks to copy elision. We don't have to waste our brain power thinking of a million different things about what could happen. It's just, hey, we want the float, it returns the float. All right, that's all well and good. So let's go a little further here. All right, what if you want to set multiple things at once? What if you want to have just like a set all defaults? What options do we have there? All right, so I'm going to get rid of this. Don't really want to mess with that. What if we just want to set all defaults? And it's like, what we want this function to do is set all the player defaults. Like, whatever those end up being. Okay, so we could, these are global, so we could just like pass them in here like this and set them all since they're global. And if this is all like one big class or something, maybe this is something that's fine. Unknown name, I'm gonna type fast and typo things, I don't care. Default hit points, 10, action points, 10, strength, intellect, 10. Since these are all 10s, we could just chain them and set them all. It's something you can do in C++, like that. That'll set all those to 10. So call and set all defaults would update these globals. But that's that's not necessarily something we necessarily want to do. Like, what if these aren't global and we're declaring them in our main? Then this isn't going to work because it's not going to have access to that stuff. So we would have to pass it in. It's like, okay, that's fine. Let's pass it in now. Let's go string. Let's do it by reference so we can actually edit it. Player name. And it's going to get real messy. And then we're going to go float by reference. Hit points, pass that in, and we just go on and on. And we basically go down the line and pass those all in. So we could do that, or, we could have, it's going to get a little messy is what I'm getting to. It's going to be a lot of code, and I'm going to show you a way that we could kind of save code, because this would just go on. We will also want to bring in the intellect by reference, so we can set that, and this would work. I'll just type it out. Strength by reference, so we can set that. Action points by reference, so we can set that. And we could just call it. So I'm going to comment out all this code for a second, so we don't really need it. And we'll go set all defaults. And then we got to pass in all this stuff. IntelliSense is not helping me out much here. Usually it does. Hit points, action points, strength, intellect. So it'll pass all those in by reference. It'll set the real ones since they're in by reference. They're not const, so it's allowed to. And that'll actually work. So let's, I don't know, let's uncomment some of these lines so that we can see what some of them are set to. I'm not going to do all of them. Well, let's look at HP and name. We should see unknown and 10 for those. So let's hit play on that. I've got an error somewhere. I typoed hit points. Okay, let's copy it down. There we go. All right, and there we go. We get the name and HP. It actually edited it. So that's another way you can do it. You can just pass them in by reference. But I'll show you yet another way that is often very handy. So we have our player, and all this stuff is tied together. So this is a great case for making a struct. All right, so let's declare a struct up here for player. Let's copy it up here, make struct. We'll just call it player, and just close it in with brackets. And there we go. Now we have an object of a player that holds all of this stuff. Okay, now that we have this full player set up here, it's just a struct. It's just a single object, or it can be. So now we could make this a lot more simple with the set defaults. For example, set all defaults. Rather than having to pass in every single one of these, we could just pass in the player struct once and then call all the same stuff, but we do have to put some preferences in front of it, like player.player name now, since it's part of the struct. I guess player name is redundant when it's already a struct called player. So maybe we'll just change that. But you probably get the point here. So now we're still taking it in by reference, but we're just doing it all at once rather than having to type it out. So it depends on your function. If it's something that you want to edit an entire struct or class, you can do it like this. But if it's always going to be kind of a mishmash of things depending on your API or your program, you might have no choice but to do it something like this. But you can also see that, like, the problem with this original one is, well, we can't just return one thing, so we can't do this style because we can't return all this stuff. You're only allowed one return type. So if you need multiple return types, you often just have to pass a bunch of stuff in by reference like this. And once again, these should all be prefaced with like out, but compiler doesn't care about that. It's just for reading purposes. So you could also do now with this set all defaults, like where here you can't return all this stuff on the left side. This one you could. So you could have a set all defaults that takes nothing and returns a player, or I guess it would be like make default character or something. Set all defaults, and that's why it works so well. Make defaults. Let's go with that. So make defaults that returns a player. And then we could, we could make a player in here, set all the stuff, return player. So that would also work. And then rather than having to do this, we could just, well, there's multiple ways we could do it. We could go player, make a new player here, make a new object. And right away, we could just call make defaults, and that would set up our player. Let's do a couple quick couts here. This would be player.name now, and player.hitpoints. So let's just make sure to actually set them. Okay, so we could do it that way, calling this make defaults, and we'll do the other one in a second, just to test. We got an error. What's the problem? It said make defaults not found. Oh, we have an S on it. All right, good enough, do that. All right, and there we go. We got the unknown name and HP10 that it took from make defaults. So the other way of doing it, by passing it in, you can do it that way too. It be this one here, set all defaults. It wants a player reference, so we go set all defaults, pass in our player. Now, if it just wants a reference, you just need to make sure it's not a pointer, basically. So you just pass in the real thing like that. Same thing, works fine. All right, and another thing, maybe you wanted your player or object to be a pointer. So you go like this, equals new player, call it default constructor. Then you want to pass in by reference. Well, you can't. See, watch here, because it's going to have an error. It's going to say could not convert, or no overloaded function to convert all the argument types, because it wants a real thing here. So all we have to do is just like before, since this is a pointer and we want the real thing, we dereference it, and then it'll work, or not. Oh, now that it's a pointer, it wants this here later. Because this also dereferences. If you go over, look up what this little symbol here does, basically puts a star in front of it on the back end. And just to prove that, basically you could do this instead of using that little thing. But this, it's a little harder to read, but it would work the same. What are we doing here? Oh, I think you've got to surround it by this first, if I'm not mistaken. Yeah. Because basically we have to cast this pointer to a non-pointer version, and that's why with parentheses. Otherwise it doesn't do it in the right order. So yeah, in general, they've just made it this little symbol here to dereference everything. All right, well, there's some examples to hopefully get you started and get you understanding some return type stuff and things, ways to call functions to edit your variables. I think that's enough for this episode. Let me know your comments down below. Any other tips, anything that I maybe missed. I tried to kind of cover everything, but it's kind of impossible to cover everything. But I think I covered the basic. So if you got any tricks or things you like to do when changing stuff in functions, let me know. And just to quickly summarize, I would say passing in by reference is often the most efficient way to do it. So that's a lot of times what you want to do. If you're returning just a variable, you want to just make sure it's not copying unless you're okay with a copy, and you just got to really pay attention to what it's doing with the memory. In a lot of these cases, like when you're passing in a pointer, you can, you could, and something I didn't cover, you could also return a pointer and do something along the lines of this. I guess I'll cover it real quick. And you make a float. I don't know. Oh, this was a 20. Let's do a 20.f here. I guess this would be like value, whatever. All right, so. And then what if you want to return value? Well, that's not going to work because it's not a pointer. But you could put a reference in front of this and return a pointer to it. But what's the problem here? Can you think of it? I'll give you a second. All right, the problem here is we're returning a pointer to this value, but as soon as we hit the end of the scope, this value is getting deleted. So this will be a dangling pointer 100% of the time. This won't work at all. You'll have a giant bug in your code. So be careful with that. If you're not sure how something works, my best advice would be in general to do it in a way works, especially if you're new. Because a lot of times you just want your program to work right, so don't introduce things that you don't understand in general. And like this, if you don't understand that this value is getting deleted and you're returning a reference to it, well, this is a very efficient return style because it's just returning a small piece rather than the entire float or an entire object. It's very buggy. It would work a little better if it were something like this, where it was just global and it stayed in scope and never left scope. Then this would pretty much work. But if someone changed this somewhere just randomly in your program, then it would return a different value. So you got to be careful with stuff like that. All right. I guess I just wanted to get a quick mention of returning a pointer as well in there. All right. Well, hope you enjoyed the episode. Let me know if you want this code. I think this code is simple enough to type up or follow along that I feel like I don't need to upload it. But yeah, also this just kind of makes the point of, if you're not sure what something does, open up your editor and start testing some stuff out and play around a little bit. All right, I'll see you in the next one. Maybe we'll do a part 2 where we talk more about like copy elision and some other little nuances and side cases. If you guys are interested, let me know, and I'll see you